Good afternoon, and welcome to today's webinar, Understanding Fecal Coliforms and E. coli Testing Methods for Wastewater in New York. I'm your moderator, Nancy Leonard from IDEX Water Microbiology. There will be a question and answer session at the end of the presentation, but feel free to submit your questions at any time during the webinar. You can use the Q&A tool at the bottom of your screen and type in your questions in the box. We'll try to answer as many of your questions as possible, but if we run out of time and you still have questions, or if you're watching as an on-demand viewer, you can submit your questions to water@idex.com. This webinar is being recorded, and a link with the recording will be emailed to everyone who registered along with a copy of the slides. This webinar will introduce you to indicator bacteria, review the enzymatic test methods for wastewater, quality control, QA and QC, and discuss specific wastewater regulations for the state of New York. I'm happy to introduce our speakers today. Our North American Regulatory Affairs Associate, Jody Freimeyer, will be walking you through the specific wastewater regulations for the state of New York. Jody received her undergraduate degree in preclinical naturopathic medicine from Johnson State College in Vermont and is currently studying at the University of Nevada to earn her master's degree in public health. She's been a part of our water business for 5 years and works with a variety of regulatory agencies to help obtain regulatory approvals for IDEX methods. She also participates in several standards organizations, including the NELAC Institute and the American Standards and ASTM. Before we get to the regulations that affect your state, please join me in welcoming Sean Dubois. Sean has a BA in biology and a VS in environmental science with a concentration in marine biology and marine ecology. Sean has been a part of the water business for 17 years, working in research and development, and in his current role managing the product support group. Sean?
Thank you, Nancy. All right, so I'm going to go over, as Nancy just mentioned, so basically start off talking about indicator bacteria. Thank you. So when it comes to indicator bacteria, what's really important is instead of looking for fire, let's look for the smoke. Look for things that are easy to find. There are plenty of pathogens and harmful agents that could be found in contaminated waters. And those could be very difficult to find, time-consuming, and expensive. So instead, we want to find those things that would be easier to find. So this would be why we look for indicator bacteria. So for a bacteria or any other organism to be considered an indicator organism, it should be present when the pathogens are present. So if there's a contamination event, those indicator organisms would also be present. They should be absent in any waters that do not contain any contamination. So they wouldn't naturally occur in the environment unless there was some kind of contamination event. They should also be present in higher numbers than the pathogens. So basically, we want to be able to have an indicator organism that is easy to find because it's going to be in very high numbers. It also should be able to survive better in water than the pathogens, and everything else, it should be easy and safe to analyze. A lot of the pathogens that we would want to look for in contaminated water would be very difficult to find, either because they'd be in low numbers or they wouldn't be readily easy to find. But also, if we were to be looking for them, it could be dangerous for the users. So an indicator organism is something that's easy and safe to find. Of course, the test should be rapid. We want to be able to get results as quickly as possible in order to ensure that the quality of the water is being maintained. It should be relatively inexpensive, and of course, it should be accurate. So we want to be able to make sure that we're looking for an organism and we can detect it confidently. So E. coli is a prime example of an indicator organism that can be found in contaminated waters. E. coli is a major inhabitant of the intestines of warm-blooded animals, which of course includes humans, and is shed in high numbers when there's contamination events. So this kind of checks off some of those boxes of what makes a good indicator organism. So they're in high numbers. Basically, they're found coming from an animal source. And they do not occur naturally in the environment. They would only come from a fecal contamination. Therefore, it is a true indicator of a contamination event. A little bit more on the E. coli, they're gram-negative and thermotolerant, so they're able to survive in elevated temperatures. So there is a large group of indicator organisms that we sometimes look for, which is the coliform bacteria group. And this includes a wide range of different types of bacteria, including Escherichiae, which would be your E. coli, but also your Klebsiellas, your Citrobacters, and Enterobacters. Now, some of these bacteria can actually be found naturally occurring in the environment, and some of them will be from both the environment or from a fecal contamination. So when we look at total coliform group, we're looking at the bacteria that are able to grow at 35 degrees Celsius. There is a subset of the total coliform group that's been called fecal coliforms. Fecal coliforms are those bacteria that were thought to only occur, of course, from fecal contamination that are able to survive at an elevated temperature. So in this case, 44.5 degrees Celsius. The problem is not all bacteria that can survive at this temperature can truly come from a fecal source. There are some Klebsiellas and other bacteria, like Citrobacters, that can naturally occur in the environment that can survive at these elevated temperatures. At the same thing, E. coli, which we know will only come from fecal contamination and not naturally occurring, some of those E. coli actually are not thermotolerant, and they can survive at those elevated temperatures. So when looking at the two groups, fecal coliform is a kind of misnomer. A better term would be thermotolerant bacteria that are able to survive at elevated temperatures. But for sake of simplicity and everything else, we'll call them fecal coliforms from now. So now I'm going to go over some different methods when it comes to measuring for fecal contamination in waters. So there's been kind of an evolution over time as to the types of testing that can be done in order to detect for fecal contamination. Starting off, some of the earliest tests that were done would be with multiple tube fermentation, MTF. This is a very laborious process that requires up to 60 steps in order to run the tests. And it took up to 4 days to get a confirmed result. And so while, being a good test starting off, it does take a lot of time, it does take a lot of skill, and results are over 4 days. So the next kind of process we come up to would be more of your membrane filtration. Membrane filtration did reduce the number of steps required to run. It takes only up to about 20 steps in order to run this method. The results can be obtained in 24 hours, but usually there's still a confirmation step that could be required, so up to additional 24 hours. So you're still looking at a 1 to 2 day test. And it's still heavily involved and requires some amount of skill and to be able to run this method. So then we come up to enzymatic tests, and this includes IDEX's Kohler, Kohler-18, and Enterolert. So enzymatic tests reduce the number of steps further to up to 8 total steps for a quantified result. And now we have confirmed results at 18 to 24 hours depending on the test. So as we can see, over time, we've made tests easier, made them faster, and more accurate. So I'm going to take a few minutes and go over the different tests for IDEX, including Kohler, Kohler-18, and Enterolert. So when it comes to all of these tests, basically they all form they have the same basic function. It's a reagent that contains several ingredients, and these ingredients have several functions. So we have basically the food for the bacteria in order to help grow our target bacteria. There are suppressants to prevent non-target bacteria from growing. And then finally, we have what are known as our nutrient indicators. And these nutrient indicators are actually what give us the signal to tell us whether or not the target organism is present in the sample. So as you see on this slide, we have Kohler and Kohler-18. And what we're looking at here is the indicator O-nitrophenyl beta-D-galactoperoxide, or ONPG. So this is used in Kohler and Kohler 18 for the detection of total coliforms when the test is run at 35, and in the case of Kohler 18, for fecal coliforms when it's run at 44.5. But I'll get into more of that later. So the way this basically works is that total coliforms have an enzyme, beta-galactosidase, that is able to utilize this nutrient indicator, the ONPG. So basically, very simple is that enzyme basically attaches and eats the beta-D-galactoperoxide. And what that does is it actually cleaves off the O-nitrophenyl group from the nutrient, which then will hydrolyze and becomes O-nitrophenol. So what that does is it goes from a colorless solution to yellow when coliforms are present. Kohler and Kohler 18 also contain a secondary indicator, nutrient indicator, 4-methyl beta-D-glucuronide, MUG, and this is used for the detection of E. coli. So E. coli has a specific enzyme, beta-glucuronidase, that is able to utilize this nutrient indicator. And this one will go from a non-fluorescent appearance to fluorescent when that enzyme is released, which is the 4-MU group. So with Kohler and Kohler 18, when testing for total coliforms in E. coli, total coliforms will produce a yellow color, which includes E. coli, because E. coli is a total coliform. But E. coli will also have the reaction with the MUG to give a fluorescence. So yellow, positive for total coliform, yellow with fluorescence, a positive for E. coli. Our other test for enterococci, known as EnterAlert, utilizes the same principle of a media that has food, suppressants for non-targets, and then a nutrient indicator. In this case, it's 4-methyl beta-D-glucoside, which is, once again, same as the MUG, where you're looking for a fluorescent response. The only difference is the food, the sugar, is actually geared towards an enzyme present in enterococci. But the same concept, eats that sugar, removes the 4-MU group, which then will fluoresce under UV light. So that's basically how the reagents work. And now we have the media, so now we actually want to utilize it in order to get a count of the number of coliforms, fecal coliform, or enterococci that are in the samples. So for quantification, it requires having the test reagent as well as the quantitray system. This includes the actual quantitrays themselves, quantitray inserts, and then the quantitray sealer plus. And the way this works is the trays are utilized for each sample, and the sample will go through the sealer and seal the tray, and then we'll go from there. So for running the sample, it's basically as easy as adding the reagent to the sample, mix to dissolve, and then that gets poured into the quantitray. The quantitray is then placed into the quantitray sealer, and the sample is sealed. So the way this works is that the sample goes into the tray, which at this point basically acts as a large bag. And then when the tray is put through the sealer has two rollers that will distribute the sample within the tray and activates an adhesive that will seal off each of those individual wells that are on the tray. Once the tray has been sealed, now it's time for incubation. So for Kohler and Kohler 18, the samples are incubated at 35 degrees, plus or minus half a degree. For Kohler is a 24-hour test with results valid up to 28 hours. Kohler 18 is an 18-hour test with results valid up to 22 hours. So after your tray has been sealed and you place it in your 35-degree incubator, the next step would be to wait the 18 to 24 hours, depending on which test you're using. And then you would remove the tray and read for your results. So as mentioned previously, when it comes to Kohler and Kohler 18 for total coliforms, what you're looking for is yellow color. Any yellow color greater than or equal to the comparator is considered a positive for total coliforms. If you do find you have yellow wells, the next step would be to place that under a 365 nanometer UV light. If a well that exhibits yellow color also exhibits fluorescence, that is a positive for E. coli. So in the one test, you get both the results for total coliforms and E. coli. If running color 18 as a fecal coliform test, there's a slight difference in how this test is run. So after you've added your color 18 to your sample, dissolved, added to the tray, sealed, the next step would be incubating at 44.5 degrees, plus or minus 0.2 degrees. So there's a difference in the temperature, and this temperature difference is very important. So once again, that thermotolerant bacteria are able to grow at the elevated temperatures, so you have to make sure that you have that 44.5 degrees. The plus or minus 0.2 degrees is extremely important for the test. If you have your water bath set lower than 44.3 degrees, then the sample will be too cold. And basically what could happen is that you actually have an increased count, because now you're letting non-thermotolerant bacteria the ability to grow, which could increase your numbers. If you incubate at a temperature greater than 44.7, now there's a chance that the temperature will be too hot for the bacteria, which would actually kill off some of those thermotolerant bacteria, which would then lower your counts. So you'd actually have a lower count than what you're expecting. So it's very important that the temperature of the water bath be at 44.5 plus or minus 0.2. With color 18, when you put the trays into the water bath, the trays go directly into the water bath and submerge into the water. They do not go in any kind of bag or other containment device. The trays are sealed, so there's no concern about sample coming out or water getting in. The trays go directly into the water bath. When the trays are in the water bath, they should be completely submerged below the surface of the water, and they should be held down by an appropriate weight for the trays. We definitely would not suggest like going outside and grabbing a brick or a rock and putting that on the back of the trays. That would not be a good idea. And you don't want to use something like a beaker or glassware full of water, because that would actually change the thermodynamics in the water, which could change the temperatures within the sample. So it's really important to use an appropriate weight for a water bath. And in the image, you can kind of see there is a weighted ring that are used for water baths. So once again, when running color 18 as a fecal coliform test, it uses a water bath with a temperature set at 44.5 plus or minus 0.2. Results are read between 18 and 22 hours. And what you're looking for is yellow color. So we're not going to look for fluorescence with this one. It's important to know the difference between the two. If you're running color 18 for fecal coliforms, you only look for yellow color. Because as we talked about before, fecal coliforms include both E. coli as well as some other non-E. coli bacteria. So fluorescence doesn't count here. You just want to look for yellow color. As mentioned earlier, we do have a comparator for both color and color 18. And what the comparator does is it gives you the minimal amount of signal in order to call something a positive. So if you're using it for total coliforms, when you run your samples at 35, or reading your fecal coliform, if you run color 18 at 44.5, what you're doing is you'll look for the minimal amount of yellow. So the comparator has the minimal amount of yellow to call something a positive. So if it's equal to or greater than the comparator, then it's positive. If you're running your test at 35 degrees for total coliforms E. coli, the comparator also has the minimal amount of fluorescence to call something positive for E. coli. So you put the tray and the comparator underneath the UV light and compare it for fluorescence. Now, this is something that you definitely want to make sure you have for auditing purposes, and it's also very helpful for when training new people and for those samples that might have, might have a question on the results. Enterolert for enterococci has a different temperature it's incubated at. The process in order to prepare the sample is the same, where you would add the reagent to the 100 ml sample for enterolert, mix to dissolve, seal in your tray, And then in Enterlert's case, it gets incubated at 41 degrees plus or minus half a degree. So it is a different temperature, it's a higher temperature. The results for Enterlert are valid from 24 to 28 hours. So after you do incubation, you take your tray out, and then we read results under a UV light. Any blue fluorescence indicates a positive for enterococci. So in this case, we're just looking for fluorescence. So in all cases, in all different types of media, the final result is going to be the number of positive wells for that test. So the next part is to actually convert that to the most probable number for that sample. So you would count the number of positive wells in your trays, record that number, and then refer to the most probable number, the MPN table, that's included with the different trays. So as mentioned, we have two types of trays. We have the quantity tray, which is a tray that has 51 wells, and a quantity tray 2000, which has a total of 97 wells of two different sizes. And basically the difference is going to be the counting range that each of them give. The 51 well quantity tray will give you a counting range of up to 200 MPN per 100 ml, while the quantity tray 2000 will give you an MPN of over 2000. So how this works is basically you count the number of positive wells and then you refer to the table. And here's an example of the 51 well table. So as you can see, the first column will tell you the number of positive wells that you have in your sample. The second column from the left gives you the most probable number, the MPN, for that sample. And the last two columns are the upper and lower 95% confidence range for that sample. So for example, if you have 4 positive wells in your sample, the most probable number for that would be 4.2. With the quantity tray 2000, you have two different sized wells, large and small. And what you do is you take the result from the large and the result from the small, and then you go to the table. The far left column is the number of large positive wells in your sample. And then across the top are the number of small positive wells. So an example here, if you had 48 large positive wells and 48 large positive wells and 25 small positive wells, you would basically follow along those two column and the row, and you'd find an MPN value of 344.1. One of the questions that tends to come up quite a bit when people are changing over from a memory filtration method to an MPN method is, I'm used to recording my results as a CFU or coliform unit as opposed to an MPN. And are these results different? And the simple answer is they're not that different at all. Basically, it is a label or unit that's associated with the type of method that you're running. So an MPN result is based off of bacteria that's grown in a liquid medium, which would include coli. CFU refers to the bacteria result that would be coming from something that's grown onto more of a solid media, so it's any kind of like agar plate, like MFC. So once again, it's basically just the label or unit associated with the numerical result. So you're still reporting the result out on a per 100 ml basis. It's just that if you're doing it from a liquid, it'd be MPN, or from a solid, it'd be a CFU. And what's really kind of important to point out is that people sometimes assume that results coming from an agar plate are a definitive result, like I can see the colonies, and therefore that's the real answer. But that's not true. If you look in standard methods, it does mention that there is a 95% confidence limit on MF methods as well, because there's going to be a chance of some bacteria not making it through to the filter, other ones become trapped and actually will become non-viable because the whole process of memory filtration is actually kind of stressful to the bacteria, or you could just have clumps. So there's still going to be a confidence range built around those memory filtration plates as well. So something else that tends to come up is if dilutions can be run with CoAlert and CoAlert 18 and Enterolert methods. And the answer is yes. One of the main benefits of using the coin tray system is that you have an option to have a tray that gives you a count of over 2,400, which will easily handle most things. But there are those chances, especially with like wastewater, where there's a sample that could have very high counts, and so the tray still can't accommodate for that. So what can be done is a dilution, and it's as simple as diluting your sample prior to adding the reagent. So basically, you just take your sample, put a certain amount in, then fill the rest of it up to 100 mL with a sterile diluent. After you've done the dilution itself, you would add the reagent, and then go through the steps as previously discussed. So a couple examples, a 1-to-1 dilution where you have equal amounts of the sample and a sterile diluent, or 1 to 10 where you have 10 mL of a sample and 90 mL of diluent. So after you do the dilution, add the reagent, seal, incubate, read your results. That result will be based on what you've done for your dilution, and basically you just need to do back calculation. So if you did a 1 to 10 dilution of your sample, you just take your MPN results and multiply it by 10 to get your final results on a per 100 ml basis. So it's basically, that's the running of the test. Very simple. If you can add reagent, dissolve, and seal in a tray, and incubate, and then simply looking for either a color or a fluorescent read. So a little bit on the quality control aspect of it now. So with any test, there's going to be some QC that might be required for testing. For IDEX products, we do a fair amount of testing on our end, and we do have certificates analysis that are associated with each one. But there'll still be some testing that would be done prior to being used in the lab. For example, of comparing the amount of QC that's required for, say, Colar 18 versus a memory filtration method such as MFC, there is quite a bit of difference. And as we can see here, that whenever you receive a new lot of Colar 18, and best practice is to run a positive and negative control when you first receive that batch in, just to make sure that results are as expected. Basically, after you run it that first time, you don't need to run QC anymore on the product because the consistency between the lot is confirmed that you don't need to test every single time you run. Unlike with memory filtration methods such as MFC, where with each new batch that's either made or purchased, you want to run positive and negative controls. There's also verifications that need to occur on a regular basis because the test results can be kind of questionable with that method. Also, with some new changes that have come through, with MFC, you have to run blanks before and after. You run up to 10 samples. And then on a monthly basis, it requires verification of 10 presumptive colonies, positive colonies, to verify that when you're reading the result, it's the true result. So there's a lot more QC that tends to be involved with memory filtration methods, especially with MFC now for fecal coliform testing. Once again, none of that needs to be done with Colar 18. Colar 18 just requires the first time you receive the lot in to test it that one time. So a much reduced amount of QC testing. And a lot of that has to do with the quality of the product, which I'll go into a little bit. IDEX does have several different ways in order it can be QC'd. You can either obtain a culture from a national collection, so such as ATCC or NCTC, and basically receive those bacteria in and then store them and then use them appropriately. IDEX also offers a line of IDEX QC, which will include a positive and negative controls for each type of products. So, for example, we have a total coliform E.coli kit that will contain an E.coli positive, a coliform positive, which would be Kleb varicola, and a non-target, Pseudomonas aeruginosa. And we also have one for fecal coliforms, which gives you a positive and negative, and enterococci. Same thing. They give you a positive and two different negatives. So, as talking about, we do supply a certificate analysis with all of the products that we do sell. They can be obtained through our website. The link is here, but it's as simple as idex.com/water, and then there'll be a link in several locations in order to access the CFAs for all of the products. And basically, all you would do is just go to that link and then click on the box, enter the lot for the material that you're looking for, And then from there, it will tell you the number of the lots materials that refer to that lot number. You click on that, and that will provide a PDF file of the C of A. And this is important to have just for your own records, but also for any audits that you might occur. So it's important to have these easily available. On all of the C of A's, it will show basically all the testing that has been done on that specific lot for that batch. And this includes both the running of target and non-target bacteria and pH and some other factors for the reagents. And it will tell on each one whether or not it has passed. And the truth is, if we had any of our tests not pass a certain criteria, we wouldn't release it. So we're guaranteeing that our products are going to work at their highest quality. And to do that, we do a fair amount of testing in our quality control lab. They receive materials from across the lot, so we verify that the results obtained from a lot should be consistent amongst the entire lot itself. QC will do all the testing that is required on their end, and then that packet of information is then given to our quality assurance team. And the quality assurance will go through those packets, ensure that all the testing that needs to be done has been done, and that everything has been done correctly. Only then, after QA has inspected all of that, will it then be approved and released for distribution. Further, strengthening our dedication to quality, IDEX as a whole does have several certifications through ISO, including 9001 and 14001. The Water QC lab itself has a separate ISO certification for 17025, which basically takes a look at our QC processes, and on a yearly basis we get reviewed in order to show that what we're doing, we're doing things appropriately and that we're releasing the best product that we can. And while this isn't huge in America, in Europe, 17025 can actually do a lot for a lab and help them reduce the amount of QC testing, because it ensures that the testing that we're doing here meets our criteria. So just to show, once again, all of the products that we sell will have a C of A associated with it, whether it be the IDEX QC, the reagents, the quantity trays, and vessels. Everything will have an associated certificate of analysis in order to have for your records for your product.
Okay, thank you, Sean. That was really informative. And just as a reminder, if you do have questions for Sean, he will be answering questions at the end of Jody's portion of the presentation, which will start now. So welcome, Jody.
Thank you, Nancy. Hello, everyone. So the U.S. EPA drives regulations in New York, just like it does for all other states. Specifically in the EPA's Clean Water Act is where it states what the wastewater regulations are, which can be found in the Code of Federal Regulations at 40 CFR, Part 136. And every so often, these regulations are updated through a process called the Method Update Rule. In the most recent Method Update Rule, done by the EPA back in August of 2017, was the EPA's final approval of IDEX's Kohler 18 fecal coliform method for wastewater effluent. After the EPA had its method update in 2017, states that have primacy can either incorporate the federal rules into the state rules, or the state can create rules that are equivalent to the federal rule, but the state rules must be as stringent as the federal. They can't be less stringent. Wastewater regulations in New York require fecal coliform bacteria monitoring that are enforced through the New York State Pollution Discharge Elimination System Permit Program, which is SPDES for short. And these permitting rules are included within Chapter 6, Part 750. Chapter 6, Part 700 is where it states the analytical test methods for fecal coliform testing, and it states they must be compliant with the EPA rules, specifically those listed at 40 CFR Part 136. However, it is possible that some wastewater permits might list a specific test method instead of referring to the general reference allowing to use any test method included at 40 CFR Part 136. So if there are ever any questions on a particular SPDES permit, it's always best to reach out to the permit writer included on the individual permit, but you could also contact a regional permit administrator. New York has 9 SPDES regions, and each region is responsible for managing their own permitting process. Additionally, each region reviews permit applications, conducts on-site inspections, making sure facilities are compliant with permit and wastewater discharging. They'll respond to any reports of environmental damage, do enforcement activities, and also answer questions. And just to quickly, briefly mention, some of these slides do have a hyperlink, which can be viewed once the presentation slides are available. So if you wanted to review any of the regulations or view who the contacts are. So once the EPA has adopted the method update rule, this change affects wastewater labs in New York by allowing more analytical test methods that can be used for SPDES permitting fecal coliform monitoring requirements. This revision can be really helpful to laboratories since, as previously mentioned by Sean, Kohler 18 quality control steps are reduced, hands-on time is reduced, demonstration of capability is easier for both a new analyst and for any ongoing DOCs that might need to be continuously done over time, and allows for more reliable data. So if a laboratory is interested in changing an analytical test method, you might be wondering what's the process for this to be done. So in New York, the Department of Health Environmental Laboratory Approval Program accredits laboratories by following TNI standards, and laboratories can change or add a new method to their scope of accreditation. Here at IDEX, we've put together the steps outlined here in a method adoption guide document for Kohler 18 fecal coliform testing. And this document will walk you through the steps needed to adopt the method and is available by request. So typically, the steps to add a new method will include passing 2 proficiency test samples, creating a standard operating procedure for Kohler 18, the fecal coliform method, and additionally, as part of your SOP, you'll want to include the quality control requirements, which are listed in the Kohler 18 package insert. However, if you do feel like you might need some help with creating an SOP, we do also have an example SOP document that is available by request as well. So other steps for adding a method to your scope is you'll want to make sure any changes to your quality systems manual are completed, especially if you don't already have IDEX listed as a vendor. You'll want each analyst to complete a demonstration of capability, document it, retain the information, and make sure to have it available if the state ever requested to view that information. You'll also want to complete the appropriate application form and pay any associated fees. Then once all the steps have been completed, the laboratory may need to complete an on-site audit. If there are any findings or corrective actions identified, those will need to be completed and sent in to the assessor. Then once all the information is complete, it would be sent to the state, then reviewed, and if granted, the method would be added to the lab scope of accreditation. So today I talked a bit about New York regulations, and I'd like to wrap up the regulatory portion with sharing a part of what I do, which is I follow various state rules and regulations to see how they periodically change over time. I'd like to provide a little information on how easy it is for anyone to follow and even participate in the New York rule changes. Anyone from the public can comment on proposed rule changes, and comments can be especially impactful to rulemakers when they come from stakeholders such as wastewater utility folks or laboratories, since you're the ones doing this type of work and you might be directly affected by any rule changes. A comment submitted to the state can include things like your opinion on the rule subject, any data you'd like to share that might be impactful pertaining to the regulation you're commenting on, or how the proposed rule change may impact your daily work. Typically, a public comment phase is open for about 30 to 60 days, but you can sign up to receive email notifications on various rulemaking activities so you can watch and track what's happening in your state. There are a couple hyperlinks in the text here on this slide, which if you choose to sign up, the Environmental Notice Bulletin is specific to the Department of Environmental Conservation rulemaking activities, but for more of a variety of topics, you could sign up through the DEC delivers. And that concludes what I have for the regulatory portion today. Thank you.
Thank you, Jody, and thank you, Sean. We do have some questions that have come in already, but just as a reminder, you can submit your questions either to Sean for technical questions or to Jody for regulatory questions through the Q&A tool in the bottom right-hand side of your screen. As Jody mentioned, I will be sending out a copy of the slides that will include all of the links so that you can link through to the regulatory information that she has in the presentation. And I will also be sending a link to the recording of this webinar that you can share out to any colleagues that may have missed the presentation. Okay, first question I believe will go to Sean. Sean, is there a separate comparator for fecal coliform interpretation versus coliform or E.coli testing?
Actually, no. There is only a comparator available for ColAlert and ColAlert 18. We do not have comparators for other products. So in the case of EnterOcocci, what we would suggest to do is, because it's any blue fluorescence is considered a positive. If you have any questions on that, it'd be good to have a negative control, where you just basically run sterile diluent with EnterOcocci added to it, and then use that as a comparison if you have any questions on what's a positive.
All right, great. That actually takes care of another question that came in. There was a question about whether or not there was a comparator for EnterOcocci. So I guess the answer to that is no. Right? You can.
Yep.
Yeah. Okay. So another question for Sean. Is it acceptable to make a dilution of the wastewater sample?
Yep. That would be something to do. As mentioned, the tray should account for it, but if needed, you can do dilution. The important thing is just make sure you do dilution prior to adding the reagent. And then when you do read your results, just to account for that dilution. But yes, it would be, if you knew you had really high counts, that would be more than the tray. Or if the sample had some kind of color or turbidity to it that might make it difficult to read for yellow color, then it would be a good idea to do a dilution in order to account for that.
All right, great. Thank you. And Jody, so you don't feel left out, here's a question for you. What do I do if my permit states a specific method?
Yeah, good question. So if a wastewater permit lists a specific method, you would want to contact the permit writer listed on the permit and ask what needs to be done to have the method changed.
All right, great. And will the contact information be on that certificate?
Yes. So the permit writer would be listed right on the individual permit. However, if there was some reason you were unsure who that was, and one of the links in the presentation will bring you to the regional contact administrators, so you could reach out to them.
And that was a slide with all the states, with all the regions on
yes.
it? Okay, great. Thank you. And now a question for you, Sean. Can I use phosphate buffer to make a sample dilution? Sean?
I'm sorry. We would suggest not using oxidant or oxidant-free, non-buffered water for doing dilutions. So something like sterile deionized water or the like for dilutions.
Okay. And again, this is for you, Sean. Can I test a sample which has some coloration, turbidity, or sediment?
Yep. As mentioned, if the coloration or turbidity wouldn't impact the ability to read the results, then you'd be able to run it straight. However, if there would be some kind of color or turbidity present, or even sediment, the best thing to do would be a dilution. And basically, that would account for removing some of the color or the turbidity. The other thing is you just have to make sure that, once again, when you're reading the results at the end, that you account for that dilution.
Okay, thank you. And this question for you, Jody. Does a commercial lab need to add cholert-18 fecal coliform to their accreditation scope?
So yes, if the sample being tested is being used for any sort of compliance testing, then yes, the commercial or private lab would need to add the new method to the lab scope of accreditation. Good question.
Okay, great. Thank you. Sean, what's the difference between cholert and cholert-18?
Well, the big difference is the time to result. So cholert, once again, is a 24-hour test that goes up to 28 hours. Cholert-18 is an 18 to 22. So that's the big difference. The next difference would be that for fecal coliform testing, only cholert-18 is available for that. But other than that, basically just looking at the time difference.
Okay, great. So you cannot use cholert for fecal coliform.
Correct.
Okay, just to clarify that. Thank you.
Mm-hmm.
Jody, do you have a method adoption guide?
Yes, we do have a document that outlines the steps for adopting the cholert-18 fecal coliform method that is specific to New York State. You just have to reach out to us and request for a copy.
All right, great. And in order to do that, you can either respond to my email that will include the recording link and the slides, or you can send an email with that request to water@idex.com. Okay. Sean, question for you. Is it okay to use an air incubator instead of a water bath?
Well, so I'll assume this is for fecal coliform testing. For fecal coliform testing, it is preferable to use a water bath. To maintain that 44.5 plus or minus 0.2 degrees is very difficult with most air incubators unless you have a really high-end one. And once again, it's really important to maintain that plus or minus 0.2. So it's best to use a water bath for fecal coliform testing because it's able to maintain that temperature a lot better than an air incubator would. If it's referring to either total coliform E.coli testing or enterococci testing, either can be used. Most will use an air incubator, but highly suggest using a water bath for fecal coliform testing.
Okay, great. And actually, we already answered this question. Is there a different cholert-18 reagent for fecal coliform testing versus E.coli testing?
Yeah, no, it's the same reagent, just a different temperature.
Okay, it looks like, I think this is the first time this has happened. We've run out of questions. We have one question that's kind of pending that we need some clarification on. But other than that, we don't have any other questions. So if that question that came in from Elizabeth, if you wouldn't mind sending us an email to water@idex.com and we can get that answered for you. Once we have a little bit more information, that would be great. So we hope that this webinar was helpful, and we certainly do appreciate your time. We know how valuable it is. If you have any questions, as I said, please send us an email at water@idex.com or visit our website at idex.com/water. And you should be receiving a recording link and a copy of the slides by the end of the week. And I hope you enjoyed the webinar and enjoy the rest of your day. Thank you very much.